right, let's just forget hydrogen for a moment. Okay, just forget that. It's just an outlier. There's a reason why hydrogen there, it's kind of special, but if we go down the periodic table, this is called a group. Okay, group 1 or 1A. So anybody know what group 1 or 1A are called? Alkaline metals, very good. Okay, so these are going to be what type of charge as an ion? Okay, these will form +1 ions. Okay. So lithium is an element, right? It's an element. But what charge would lithium like to be as an ion? Okay, what about sodium as an ion? +1. Potassium as an ion, what charge? +1. Rubidium as an ion, +1. Again, forget about hydrogen for a moment. Actually, hydrogen will also be +1, but we're not going to talk about that. It's something different. Right, when you form an ion, what does that mean? So an ion, by definition, is a charged particle. It's a charge. So what are the two charges we know of? Okay, the two charges that we know of are positive and negative. Okay. So a positive charge is called a cation. Okay, do we remember this? And what's a negative charge called? N-negative, anion, N-negative, anion, negative. Okay, a negative charge is called an anion. So as an ion, okay, what are you giving or taking? Are you giving away protons? Yes or no? No. Are you giving away neutrons, which we really didn't talk about? Okay, so what are you giving away? Okay, electrons. So if lithium becomes positive, what did it give away? Okay, it gave away 1 electron. Okay. You gave away 1 electron. So by being a cation, you give away 1 electron. Okay, to become an anion, what do? Actually, you don't give away 1 electron. You give away 2 electrons. Okay, you give away 3 electrons. As an ion, what do? You take electrons. Okay, so it could be 1 electron, 2 electron, 3 electrons, so on and so forth. Okay, so we have the alkaline metals. Okay, so this one here is called group 2 or 2A. Okay, do you know what the names of these are called?
Alkaline earth metals.
Very good, alkaline earth metals. And what charge would they be?
+2.
Very good, alkaline earth metals. So what does that mean? Okay, if beryllium, Be, were to form an ion, what charge would it be? Okay, what about magnesium?
+2.
You know, magnesium, have you heard of magnesium ion? Do you guys take that as a supplement? Okay, what about calcium? Okay, so these are the, the nursing, the science people, these are actually found in our body. +2 ion, magnesium +2, okay, so on and so forth. So these give away not 1, but how many electrons? 2. All right, let's hop over here. We're going to call this group 16. Some periodic tables call it 6A, so whichever one you printed out, just know the top is called the group. And what charges would these like to be?
-2.
Okay, these would form -2 ions. So oxygen is oxygen, but as an ion, what would it be? O-2. Okay, what is O-2 called? It's called oxide. Okay, so here we want to utilize our flashcards. So you bring this to the exam and also bring your flashcards to the exam. This is called the oxide ion. You're Amanda, right? I'm learning the name. So. Okay, so that's oxide ion. What would S-2 be? Sulfide. This would be selenide. All right. So group 17 or 7A. Okay, these have a special name and they're called, all right, very good, the halogens. Okay, you guys seem like a very good class, so good job. Okay, halogens. And what charge would they like to be? So -1, what does that mean? For fluorine to become fluoride, what did it have to do? It would grab 1 electron. Okay, what about chlorine to become chloride? It would take 1 electron. Okay, what about these? Oxide, sulfide, what do? They took 2 electrons. Okay, and then we have here royalty in the periodic table. This is called group A, 8A. Okay, you may also have periodic tables called this group 18, and these are called the halogens, okay, or inert gases.
Isn't group 18 noble gases?
Noble gases, correct. Inert gases or noble gases, yes. So these are inert. Okay, they're not very reactive. Okay, they're also stable. Okay, they're stable because they have a filled electron shell. Okay, 8. 8 is that number. We'll talk about that in the end of the term. Okay, they have a filled electron shell. Who have a filled electron shell? What group? 8A, group 18, noble gases, inert gases, all of those are correct answer. So they have filled electron shells. All right, so a question for you guys here. Let's look at sodium. Okay, how many protons are in sodium? 11. Okay. How many electrons are in sodium? Electrons. 11? Who said 11? Who said 11? You're right. Okay, you have 11 electrons. Okay. This is a neutral element. So how many protons? Invariant is 11. How many electrons? Did it gain or lose anything? It is also 11. Okay, what about sodium plus? How many protons? 11. How many electrons? It took 1 away, so it is 10. Okay, what other element in the periodic table has 10 electrons? Neon. So, because sodium gives up an electron, it becomes noble. It has the same electron configuration as its nearest noble gas, and that is neon. Okay, that's why all of these like to be +1. Let's take a look at potassium as another example. How many protons in potassium? 19. How many electrons in potassium? How many protons in K+, potassium ion? Bananas, I believe, have a lot of potassium ion, right? How many electrons in potassium ion, K+? What other element in our periodic table has 18 electrons? So potassium likes to be +1. Why? It becomes stable. Okay, it gets one of these filled electron shells. Okay, that's why all of these like to be +1. Okay, forget about hydrogen. That's a different ball game. Okay. Magnesium. Okay, how many protons in magnesium? 12. How many electrons magnesium? What about +2? 12 protons, and by giving away 2 electrons, Mg +2 becomes stable. It becomes a filled electron shell, and it becomes noble. It becomes noble. How about this oxide ion? How many protons? Let's first do oxygen. How many protons in oxygen? How many electrons in oxygen? Good. How many protons in oxide ion? 8. How many electrons in oxide ion? Who said 10? Okay, who said 10? You're right. 10. Why is it 10? If I take 2 electrons, 2 E minuses, I become -2. Yes, sir? Correct. What other element has 10 electrons? Neon. Okay, so these guys here, the group 1 and 2A, the alkaline metals, the alkaline earth metals, like to react with group 16 and the halogens. They like to react, and the way they react is by forming an ionic compound. Okay, there's 2 types of compounds. One is called ionic, the other one is called covalent. An ionic compound is what? What react? The ions react. Okay? Let's do something very simple, a very simple ionic compound. Let's do a very simple ionic compound here. What would sodium like to be as an ion? Sodium ion. What would chloride ion be as an ion? Is it +1, -2?
-2.
Chlorine would be -1. Okay, all the halogens are -1. All right, so for an ionic compound, which is between 2 ions, okay, we're going to do something. This is how I learned it. It's from my teacher, so I'm going to teach it to you. We do what's called switcheroo. Okay, this is for ionic compounds. So you see that 1 in the +1? Okay, that's going to go here. You see the 1 in the -1? That's going to go here. So the formula for Na plus going to Cl minus, what is its formula? Well, what is the name of this compound? This is sodium chloride. Okay. Sodium chloride. Is it ionic or covalent? Okay, an ionic compound would be like one of these guys with one of these guys. But ionic compounds can also form with the transition metals. These have different charges, okay? These have different charges. They're all over the place. Okay, these are all over the place. This is also called, besides the transition metals, these are also called the D block elements, because all the electrons can reside in the D shell. Okay, more on that later. Okay. Transition metals, D block elements, so on and so forth. Okay, one thing I want you to know about these D block elements, they're also ionic. They can form ionic compounds with the nonmetals. Okay. To the left of the staircase, these are going to be the metals. So they're going to be cations. That is this way on the staircase. Okay, this way on the staircase, these are nonmetals. Okay, these are going to be anions. Okay, if you're going to form an ionic compound. So these transition metals, let's get back to them. They can have multiple charges, all right? So let's take an example of iron. Okay, let's focus on iron here. Okay, iron can have two charges. Okay, iron can have the charge of +2, which is what makes your blood red, right? Iron +2. Okay, but iron has another oxidation state. It has another charge that is +3. This is blue in color. People who have blue, their blood is blue, have iron +3. It's called methemoglobin, but we don't, it's not of our concern. Okay, iron +2 in the hemoglobin, it's red. Iron is blue because your blood is blue because the iron is +3. That's methemoglobin. That's a disease that some people carry. Okay, the point is that these inside this red triangle, these inside these red rectangle have different oxidation numbers, different charges. They have different charges. Okay, the transition metals. Okay, another one would be copper. Okay, we have a copper in a +1 form, copper have a +2 form. Okay, different charges for the transition metals. Okay, iron +2, did it take 2 electrons or give away 2 electrons? Gave away. Okay, so we still have the metals giving away electrons. We still have the non-metals taking electrons, but these can have differing oxidation states, or they have differing charges. Let's just say they have differing charges. Okay, it varies. The reason why they have different charges is something we'll talk about in later chapters, but it's because of this. The electrons sit in the D shell. Okay, a shell that's called D, which allows them to have different charges. So a lot of the semiconductors, electronic industry, all of those things will utilize these types of metals. Okay, cadmium is used a lot, copper, nickel, cobalt. Okay, the semiconductors, transistors, they involve utilization of these transition metals. All right, so these can also form ionic compounds. All right, so let's just take, instead of sodium, let's take Fe+2 and react it with Cl-. Okay, Fe+2 and react it with Cl-. Is this an ionic compound or a covalent compound? Okay, what would be the formula when Fe+2 reacts with Cl-? You see this 2, it's going to go down here. Okay, you see this 1, where will it go? Down there. This is switcheroo. For ionic compounds, I want you to remember switcheroo. You switch the numbers, don't switch the charges. Switch the, what do you switch? The numbers, don't switch the charges, okay? So what's the formula for this? Okay, what's the name of this? Is this iron chloride? Okay. And because it's a transition metal, you have to put it in Roman numerals. Okay, this is one of the things that causes confusion, but it's a transition metal, so it's iron 2 chloride. How come this isn't sodium 1 chloride? Correct, it's not a transition metal. Yeah. Okay, so if you see this, how do you designate the charge? You designate the charge with a Roman numeral. Okay, can we do this? Okay, Roman numeral. For what elements? Inside this red box. Okay, they get Roman numerals. Shall we write that down? And then finally, if you give or take electrons, you become an ion. What about the number of protons? If you change the number of protons, what do you change? You change the element itself. If you change the number of neutrons, what is that called? Okay, the same element, different number of neutrons. Okay, these are isotopes. Okay, isotopes. Okay, so the best example of isotopes would be carbon, but all of these have isotopes. Every element here has isotopes. This is the reason why you have that weird decimal place here. Okay, why isn't it a perfect 12? Okay, well, because it is not a perfect 12 is because 99% of carbon is 12 mass number, protons and neutrons. There's that 1% that is 13. 1%. Okay, so this is called isotopes. So, natural abundance. What type of carbon do we mostly find here on Earth? C12. What's the rare form of carbon that contributes to this messy number? C13, which is about 1%. You do not need to know these numbers. Okay, we just know that that's why these numbers are complicated decimals, because there is not just nitrogen 14, but there's a nitrogen 15. Okay, there's not just a fluorine 19, but there's a fluorine 18. Okay, there's not just a neon 10, there's a neon, 11 or something. Okay. So what are isotopes then? If I were to define an isotope, or if you were to see it on a multiple choice in the exam, how would you define an isotope? Same element, a different number of neutrons, okay? Okay, this is called an isotope. That's why carbon has 12.01. 1% of it is C13. The other 99%, the bulk in the universe, is C12. Okay. All right, another couple of things here before we'll move on to our notes. Going left to right is called a period. So this is period 1, n equals 1. I'm sorry, this is n equals 2. Okay, the first row is n equals 1. Okay, the second row is n equals 2. Okay, what's the third row called? Period 3. N equals 3. Period 4, n equals 4. Okay. Period 5, n equals 5. Okay, going left to right, it's a period. Okay, so what period is zirconium in? 1, 2, 3, 4. Period 5. Okay, row 5, but we use the word period. Okay, what period is aluminum in? Period 3. Okay. What group is aluminum in? 5A, 4A. This would be group 3A. Okay, 3A. Or you can call it group 13. You know, a lot of these periodic tables, they actually have the group already labeled, so you don't even have to worry about it. But some periodic tables, they don't have the group labeled. Okay? But going up and down is a group, going left to right is a period. What period is fluorine in? Period. And what group is it in?
17.
17, or some periodic tables will call it 7a. And what's the name of group 17, also known as?
Halogens.
Halogens. Okay. All right, we have an ionic compound. We also have what's called a covalent compound. Okay, we have an ionic compound and we have a covalent compound. A covalent compound uses prefixes. Okay, it uses prefixes. Covalent compounds is not transferring of electrons, but what of electrons? Okay, we're sharing electrons. This is your double bond, triple bond, single bond. Okay, and this will be between two or more nonmetals. Two or more nonmetals. So, what is an ionic? Transferring electrons. Okay, I give one electron and Noah takes it. We are an ionic bond. I share one electron, he shares his electron, we form a single bond. What type of compound are we? Okay, we are a covalent compound. Covalent. Okay, two or more nonmetals. Okay, what's a good example of a covalent compound? Okay, everybody breathe in, breathe out. What did we breathe out? Carbon dioxide, CO2. Okay, let me draw you the structure of CO2. You do not need to know this for this exam. Okay, it's a C double bond O and a C double bond O on the other side. That oxygen carries some electrons. Okay. But the idea is that we are sharing. The carbon is sharing actually two electrons. Oxygen is sharing 2 electrons here and there. Okay, on the left and right. This would be a covalent compound. All right, couple of things for future reference. These are the rare earth metals, so you know your iPhone screen and your cell phone screens. The touch screens are kind of made of these things. Okay, these are called the F block. These are also called the rare earth metals. Rare earth. Okay, so I will not cover that in this class. Group 1 and Group 2A are also known as the S block. I'll just put it here. Transition metals are the D block. And then everything from here is the P block. It just means the electrons go in the p orbital, the electrons go in the d orbital, the electrons are in the s orbitals, the electrons here are in the f orbital, which I'm not even going to cover anyways. Okay, so this is also called the p block. Okay, what do you think about metals? Those that are to the left of this staircase. Well, we know they give away electrons and form cations. One thing you should know about metals is that, for the most part, they're conductors. Okay, they conduct electricity. Okay, they're conductors. They're usually solid, but some metals can be brittle. And the most important thing is that they will, for our course, they're going to give away electrons. Okay, they're going to give away electrons. Okay, what do you guys know about nonmetals? non-conductor. Okay. What we need to know for this class is that they will not take away electrons, but they will not give away electrons. What will they do? They take electrons. Okay, they'll take electrons. And most of these are not going to be solids. Most of these are going to be gaseous or gases. Alright, so this was a very quick review of that video, so you can use this periodic table on your exam. You never memorize a periodic table. So, alright, I'm going to quickly go over this stuff because all of it is really here, so I'm just going to go a little bit fast. So we know what we need to know about the periodic table. Up and down is a group, left and right is a row, metals, nonmetals, S block, P block, D block. All right, the way these atoms are arranged in an element are going to be different. So look at iron. Iron is a metal, and the atoms are kind of arranged like this. Okay, this is gold. Gold is a metal, but those gold atoms are arranged like this. So the atomic arrangement is going to be different. Okay, how the atoms are arranged. Here they're kind of arranged like sardines. Here they're kind of arranged like a honeycomb. Just like that, all these metals will have different arrangements of their atoms. All right, we kind of remember, hopefully, how an atom is. This is our conception of the atom. Our conception is that in the center we have a cloud of protons, which are positively charged. We have a cloud of neutrons, which are negatively charged, which are neutral. We have a cloud of protons which are positively charged. We have a cloud of neutrons which are neutral in charge. And then we have a cloud of electrons that surround this. Hey, have you guys heard of electron density, electron clouds? So this is our conception of an electron. Okay, it's not a particle, it's more like a cloud, so it's density. And these are going to surround the protons and neutrons. So the electrons are going to be kind of situated here as a cloud, as a density. Okay, like a cloud, the clouds up in the sky. It's like that. And the electrons are going to be in orbitals, like the s orbital, the p orbital, the d orbital. They surround the nucleus, which is the protons and the neutrons. Like a cloud. Okay. It's not so much a particle, but like a density, like a cloud. All right, we have compounds, so the important point here, no decimals. No decimals, okay? Nice round numbers, okay? And then I use them the same way, like a molecule. that would be like an O2, okay, a Cl2 and N2. Those are the same elements. And a compound would be different elements. But I kind of use them interchangeably. Okay, so in another class, the water molecule, right, oxygen compound. But it's just kind of like, it's very technical, but a molecule and a compound, to me, I use them interchangeably. So a molecule, let's say, would be the same element combined. A compound will be different elements combined. But I guess I'm a bad teacher. I use them one and the same, okay? That's too technical, but right. So Dalton's law of multiple proportions. This is kind of the same thing here. Essentially, they're going to combine in definite proportions. In other words, no decimals. Okay, it's CO. It's CO2. Okay. Okay, it's NaCl. Okay, it is FeSO4. Okay, these are just 1-to-1. Okay, or 2 hydrogens, 1 oxygen, 1 carbon, 2 oxygens, 1 manganese Mn to 4 oxygens. Okay, so whole numbers, no decimals. And then we have the law of conservation of mass. Okay, basically mass or energy cannot be created or destroyed. Everything must be accounted for. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of these small atoms. Okay, we'll look at here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, every atom in your equation must be accounted for. Okay, whether it's the atom, whether it's energy. Okay, everything has to be accounted for. Nothing can be created and nothing can be destroyed. Right, so these are kind of some 2 laws that govern chemistry. Okay, conservation of mass and the fact that these atoms come together in nice whole numbers. Okay, no decimals. We always round things up to the nearest whole number. All right, so a couple of table knowledge here. Electron, look at the mass, 10 to the minus 28 grams. Can you believe that? 10 to the minus 28 grams. Okay, we're going to call E as E minus. Look at the proton, 10 to the minus 24 grams. Plus charge. Neutron, 10 to the minus 24 grams. Look how small that is. I cannot fathom anything 10 to the minus 28 grams, 10 to the minus 24 grams. Okay. And the neutron will be neutral. So kind of what we've talked about before, the electrons are going to be outside. Yeah, go ahead.
Question. So when we are saying how many neutrons and protons there, what's the unit? Are we using mole or?
Say it again.
Like when counting the neutron and proton, right, and their masses, what units are we using? Or we don't use any unit?
The number of protons?
Yeah.
We don't use any units. It has 12 protons. Just like that, yeah. Now it has a mass, but we don't use units, yeah. It's a good question. There's a unit of charge called coulomb. Coulomb. That's sometimes if we want to designate how much charge, we'll use coulombs as a charge unit. Right, so we have our element, we have our mass number here, we have the atomic number. Sometimes the atomic number is called Z. Anybody remember what the mass number is? What's our mass number? Protons, neutrons. Mass numbers, number of protons and neutrons. Okay. So on the exam, that's coming up soon, there'll be like how many protons, how many neutrons, and how many electrons. Can we do this? Are we confident to do this? Let's look at this one here, hydrogen. Okay, how many protons and hydrogen? Okay, how many neutrons? How many electrons, let's say? 1. Okay, how many neutrons here? It'll be 0 neutrons. Okay. You're going to take the mass number, which is the mass above, subtract it from the atomic number, which is the number below. How about this one here? What element is this called? It's the same hydrogen. How many protons? How many electrons? How many neutrons? How about this one here? How many protons? How many electrons? How many neutrons? What's the name of this element? Hydrogen. So what are these three hydrogens called of each other? These are the three isotopes of hydrogen. So there's three versions of hydrogen. Okay, there's one that's H1. There's one that's called H2. This is called hard water or deuterium. And this is tritium, which is radioactive, which is barely there. Okay, so of the hydrogen, this is like 99% of the hydrogen in our planet. But there's always that little bit that's H2, and then a very, very, very tiny amount that decays, that's H3. Okay. But these are called isotopes of hydrogen. So let's do some practice problems like this. These will appear on the exam. So let's go ahead and do this here. Something very close on the test. All right, how many protons in sodium? Okay, how many neutrons? How many neutrons here? And how many electrons? 11. Okay, what if I were to change that to not 2011 Na, but 2011 Na plus? How would I make that change? Okay, now can we do the same problem? How many protons? How many neutrons? And then how many electrons? Are we okay with that? Should I move on to part B? Feeling a little bit confident about this? We're not so confident. All right, we got a lot more to practice, so we'll get the hang of it. How about 2211 Na? What do you guys think? How many protons? Okay, how many protons? You just read this number here. Okay, read that number. Okay, this is the atomic number. It is invariant. How many neutrons? How many electrons? Okay. How about O17? Oxygen 17. How many protons? 8. How many neutrons? 17 minus 8 is 9. And how many electrons? Okay, if oxygen were to form an ion, what ion would it be? What charge? Okay, we call it the oxide ion, if we remember our flashcards. All right, and we will do the same thing. 8 protons, 9 neutrons, but this time around, what has changed? Okay, 10 electrons. Okay, both of these have 10 electrons. Okay, so these are both isoelectric, same electron configuration. Okay, same number of electrons. What else? Excuse me, has 10 electrons? Okay, so neon, sodium ion, oxide ion, neon, okay? All inside this big circle, they're isoelectric. What type, if sodium ion and O minus 2, would they react with each other? Do they like each other? Yes or no? Why wouldn't they? Like, this one is positive, that one's negative. Don't they attract? So the pluses will attract to the minuses. The minuses will attract to the pluses. What would they form if this were to react with this? And what type of compound would it be? It would be ionic. Oops. Remember, Na is always plus 1. Oxygen as oxide will be minus 2. This is called oxide. What would its formula be, and what would its name be? It would be what? It would be sodium oxide. And what would the formula be, Amanda? Would it be Na minus 2O plus? You just switch the numbers, okay? So I see this a lot. Okay, so let's not do that. Okay. You just switch the numbers, as somebody said. Okay, so what will the formula be? It will be Na2O. Okay, is this ionic or covalent? Okay, there's 2 ways to tell it's ionic. What's one way? One is it's a metal and a non-metal. What's the other way? What's the second way that you should know it's ionic? The positive and the negative. Very good. Positive and the negative, yes. That was a big distraction. Let's get back to carbon-14. What do you guys think? How many protons, neutrons, and electrons are carbon-14? Carbon-14. 6 protons. 8 neutrons. How many electrons? 6 electrons. Okay. Are we okay with this? Comfortable? Yes, sir. Oh, thumbs up. I'll take that. Thank you. I like that. Happy students make happy professor. Okay. Right, what is the atomic number of an element if one of its isotopes has 117 neutrons and a mass number of 195? What do you guys think? How would we do this? Gerardo, right? Yeah. Gerardo. Atomic number of an element if one of its isotopes is 117 neutrons and mass number of 195. So mass number is protons plus neutrons. So how will we get the number of protons, Gerardo? I'm just picking on you here. We'll take 195, and what will we do? We will subtract 117. Okay. So what's 195 minus 117? Don't tell me I need to break out the calculator for this.
78.
Yes, 78. I was going to break out the calculator. I was going to use the calculator for that, but it's 78. So this will be 78 protons. Okay, so what element in the periodic table has 78 protons? Okay, look at our number here. What is 78 protons? Okay, this looks to be platinum. So the name of this element is platinum. Okay, platinum. Yes, sir. Noah?
Mass number, wouldn't we just look at the atomic weight? We could have found that same answer as well.
Yeah, but because of isotopes, the atomic weight is weird. It's not 195, it's 195.078 because of isotopes. By the way, on the exam, if I ask you protons, neutrons, and electrons, same problem, I'll give you 195. Okay, I won't give you 195.078. Okay, that's just confusing. So you'll get whole numbers in this type of problem. You see what I mean? I won't give you 10.811. I'll give you 11. Okay, I won't give you 12.0107. I'll give you 12. Okay, how many protons, neutrons, and electrons? For carbon, 12. Not carbon 12.0107. Any questions or comments here? So let me take the last 15 minutes or so. So do we know the metals properties? Okay, conductors. In terms of electrons, what will they do? Give away electrons, and what will that make metals be? Anions or cations? Okay, so conductors give away electrons, cations. Okay, what about the nonmetals? Okay, it's going to be the exact opposite. Okay, they're going to take electrons, and if they take electrons, well, yes, they become anions. Okay. One are conductors, the other are non-conductors. If metals and nonmetals come together, what type of compound is that? Okay, ionic. Okay, if two nonmetals come together, like carbon dioxide or oxygen, O2, what is that called? So two nonmetals, and then metal and nonmetal. Okay, this gets switcheroo. Ionic gets what? Switcheroo. Right, we talked a little bit about molecules and ions. So there's some polyatomic molecules, or polyatomic ions, I should say, that I'd like for you to know. Okay, I'll just throw some out and let's see if you remember them or if you've been doing your flashcards. You can take your flashcards to the exam, but let's just go over some here. Anybody know what this is? Carbonate? Who said carbonate? That's correct. Carbonate ion. Okay. Okay, this is 1 unit. Okay, the whole thing is what charge? -2. Okay, the whole thing is -2. Okay, what about this one here? Their flashcards. What are they called? Anybody have their flashcards? Nitrate? Nitrate. Okay, nitrate ion. How about this here? Sulfide, if you remember, was S-2. So what will S? What is SO4 -2? It will be sulfate ion. Very good. Okay, if CO3 -2 is carbonate, SO4 -2 is sulfate, what do you think PO4 -3 will be? Okay, phosphate. Okay, so maybe 5 minutes a day, you kind of go over these. Again, you don't have to memorize them, but just makes it a little bit more easier. This one is positively charged, okay? N plus 4 H's, the whole thing is positively charged. Anybody know what this ion is called? Okay, this is called the ammonium ion. Okay, so here are some of our flashcards that we can try to pick up on. NO3 minus is nitrate. There's also an NO2 minus. And what would this be called? Not nitrate. This would be the nitrite ion. Total charge is -1, -1. Okay. We have a sulfate ion, but we also have another version. That's SO3 -2. This is not the sulfate ion, but it's called the sulfite ion. Very good. Okay. Total charge is -2. Okay. Okay, here's one that we'll use a lot in future chemistry classes. Okay, anybody know acid-base chemistry? Okay, this one is a base. Okay, what's the name of this ion? Hydroxide ion. Very good. Excellent. Okay, very good. Who said that? Nice work. Hydroxide ion. All right, can we possibly memorize these? If not, at least know what they are for the exam. Okay. So the whole thing is minus. The whole thing is minus. The whole thing is -2. The whole thing is -1. Okay, these are all polyatomic ions. Actually, these are all ions. Okay. So the whole thing carries the charge. Okay, as an example, okay, I'm going to take potassium ion. What charge would that be? and I'm going to react it with carbonate ion. What charge would that be? -2. What would be the name of this, and what would be its formula? The 1, not the plus, the 1 goes here, the 2 goes there. So what's the formula and what's the name of this if this were to appear on an exam? You got the name right. What's the formula? Ionic or covalent? Okay, there's 2 ways we know it's ionic. What's one? The pluses and the minuses, and then the other one? One is a metal, and the other is a non-metal. Okay. Okay, how about one more here? We'll take iron plus 3, and we will react it with the phosphate ion. Actually, okay, yeah, that's fine. What is its formula and what is the name? Okay, this 3 is going to go here. This 3 is going to go there. Now be careful. What will the formula be? 3. Now what? PO4 3, but the PO4 gets the 3. The PO4 gets the 3. So you gotta put parentheses. The whole PO4 gets the 3. So this is the formula that's correct, and you'd be right. But what some scientists do is they reduce it. Like in math, they reduce it. So what's the common denominator between 3 and 3? So you can also say FePO4. This is a confusing example, but yeah, because we reduce it. Okay, this is called the empirical formula, most reduced. Empirical formula means most reduced formula. Can you reduce K? Can you reduce 2 Ks and 1 CO3? You cannot reduce 2 and 1. Okay, this whole thing is 1. This whole CO3 is 1. This whole PO4 is one thing, total charge -2. This whole CO3 is one thing, total charge -2. This whole PO4 is one thing, total charge -3. Okay, how will we name this? Realizing iron, where is it in the periodic table? How will we name this? Iron, phosphate, missing anything else? And how will we put the 3? Yes, ma'am. So this is how we do this, okay? I'm going to take manganese. It actually has a version that's +3 Mn. And then we'll react it with hydroxide ion. Okay. Ionic or covalent. Okay, there's 2 reasons it's ionic. 1, positive go with negatives. Number 2, metal with all the nonmetals. So what would this formula be? It would be Mn OH3. Do I put OH3? Put MnOH3. Okay. The whole thing gets the 3. And what would this be called? Manganese. Where is it? Manganese is inside the transition metal block, so it'll be Roman numeral 3 hydroxide. Okay, is this kind of making sense? maybe a little bit, somewhat. Okay, sometimes you may have to reduce it. Okay, let's just do one more here. How about NH4 plus with SO3 minus 2? Okay, this is ionic because it's a pluses going with the minuses. So the 1 is going to go here. The 2 is going to go there. Okay, so it's going to be NH4 2, but what should I put with the NH4? The whole thing gets the 2. The whole thing gets the 2. Okay, SO3, the whole thing gets the 1. The whole thing gets the 1, but we really don't need brackets. The whole thing gets the 1. Okay, what would be the name of this? NH4 plus is ammonium. SO3 minus 2 is sulfite. So how would we name this? Ammonium sulfite. So some examples of ionic compounds here. All right, cations, just let me wrap up here with a couple of more wrap-up points. Cation, they lose electrons. So what would the atomic radius be, the size of the sodium ion? Would it be larger or smaller? Smaller. Okay, so the atomic, or I should say ionic radius. Okay, so you lost that 1 electron density. What about an anion? Okay, a larger ionic radius because it gained that 1 electron. It gained that electron density. So anions, because they take electrons, are bigger. Cations, because they lose electrons, are smaller. Okay, so make sure you review some of these polyatomic ions for the exam. Of course, you can use your flashcards on the exam. All right, so here are some example problems. I'll let you guys do this at home. Something like RB, positive. So on the exam, I'll give you 85. Okay, I'll give you the 85. Okay. So something like AG plus. Okay, I won't give you the decimal. Okay, I'll give you 108. Okay. So something like this on the exam. Okay, I minus. Okay. You'll see it as 127. Okay. So are you guys comfortable doing this for the test? Yes or no? Okay, so I'll give you the answer key on Thursday's class for that. And then we will wrap up on Thursday going over some nomenclature. Okay?